Okay, let's do one here so we can work with it a little bit. We are going to find the area of the region. Area of the region between the graphs of f of x is equal to 1 over the square root of 9 minus x squared, and the x-axis on the interval from -3 to 3, parentheses. All right? Now, I don't expect you to really know what that graph looks like. It's cool if you do, but we got a little, oops, extra here. Oh my. Oh my. Oh, you guys. What is going on? Whew. It's a little wonky donkey, but we're going to make it work. That was quite a thing, wasn't it? Okay. So here is what the graph actually looks like. And that's why you can see it's from open parenthesis to open parenthesis, because you have those asymptotes there. And that makes sense, right? Positive and -3 is what's going to put a 0 in that denominator. Okay, so what I'm actually doing is I am integrating from -3 to 3 of 1 over the square root of 9 minus x squared dx. However, you have an issue at both of those places. Now look at the graph here for just a second. It's the same, right? It's symmetric. So from here over, if I'm looking at this side of my graph, that is the exact same as the other side. So we're going to get smart on this, is what the moral of the story is. We are actually going to integrate 2 times from 0 to 3 of 1 over the square root of 9 minus x squared dx. Because what is an integral? The area under the curve. So if I have this area under the curve and it's the exact same as this area under the curve, can't I just take that times 2? Sure you can. Sure you can. There's nothing wrong with that. However, we still have the issue over here with this 3. So because I have that issue, we're going to have to do a limit. So we're going to take the limit here as, I don't know, b, why not? It's on the top. B approaches 3 from the right or the left. Good, from the left, because I'm going from small to big up here, right? So I'm approaching from the left, approaching 3 from the left, okay? And then I have 2, and then I'm going 0 to b of 1 over the square root of 9 minus x squared dx. Okay. So what's that pattern? The square root of 9 minus x squared, what is that? Yeah, inverse sine, right? We already learned that, and they'll keep coming up. Anything you learn is fair game. So the limit as b approaches 3 from the left here, I've got this 2. Now we've got inverse sine, and remember a is equal to 3, right? X is just x, and remember for sine there is no 1 over a in front, it's just inverse sine of x over 3, and then I'm going on my bounds here from 0 to b, and then we just get to plug it in. All right, so the limit as b approaches 3 from the left of 2 inverse sine of b over 3 minus 2 inverse sine of 0, because 0 divided by 3 is still 0. All right, so remember when you have inverse sine, so we talked about this in chapter 7 with their inverse trig. Your sine has to go between negative pi over 2 up to pi over 2. That's the only values that you can look at here for inverse sine. I know 0 goes to 0, so we're not worried about that, right? That's over here at 0. But now we're going to plug in the value, because remember, that's how you take a limit, is you plug it in. So this is 2, inverse sine of 3 over 3. So I want to know what's the inverse sine of 1. Yes, so sine up here at pi over 2, that is where sine is 1. Okay, so then this is going to be 2 times pi over 2, which is just going to be pi. And because that's a number, it converges. Good job. All right. Now, make your life easy. If you have something that looks like this and you can work it over, because it's 0 to 3, I'm not looking at bounds on both sides of it. Okay. Can you do bounds on both sides? Yes. Would it be a pain in the butt? Yes. Would you get the same answer? Yes. Right? Yes to all of that. Be smart. Efficient. You know, that's what I keep pushing you toward all the time.